Now with that we can move on to concept scoring. The concept scoring in fact is a more refined exercise. We are going to look at these each and every concept against different criteria in little more detail, uh, and we'll be considering only the concepts that are selected after screening for this exercise. So we are trying to do a little more analytical exercise on the different concepts. Now in this exercise we are going to use some weights and weighted sum of different ratings that we assign for each concept against each criteria. Therefore, selection of weights or the important weights for each criteria is very important. And of course, you have the freedom to decide what's the weights going to be for your one. And again, there is no hard and fast rule to decide these things. That is your experience. And also, since this is an iterative process, you might assume certain weights at the beginning and do the analysis, and then you could change the weight slightly, tune up the weights, and see how the overall results would affect the change of weights, slight changes of weights. So that is we call sensitivity analysis. We'll look at those later. So usually the weights are represented in terms of a percentage. So these are the selection criteria that we looked at in the example, and this has to be replaced by your selection criteria, and each and every criteria, depending upon its importance, you could assign a weight. And of course, if you have a hierarchical structure for the criteria or the need analysis that you looked at earlier, customer needs that you looked at earlier, then you can go a little deeper and look at this hierarchical secondary level criteria or activities in deciding the weights. For example, there's a famous example given in that book that is about pre-filled syringe, and in that case they have identified a hierarchical list of customer needs. For example, for ease of use, they have the subcategorized into three: ease of injection, ease of cleaning, and ease of loading. So these are the three aspects as far as the usage is concerned in this particular syringe. This is an injection syringe, and this is the primary need, and this is the secondary need. These are the secondary needs. So likewise in your exercises also, you might sometimes identify secondary needs like this. And if you have such a structure, you could think about these things also when it comes to deciding your weights. The step one is, as I said earlier, the same 6 steps need to be followed in scoring also, which we followed in screening process. So the first one is prepare the selection matrix. So the selection matrix for scoring is not identical to the one that we looked at earlier for screening. So now we have certain more refined details. We have to have weights that we have decided earlier, and then we'll have to rate this each and every criteria with reference to the reference, and then we'll have to assign weights and etc. So these are the concepts that we have selected from previous analysis. This reference, and we can have some combined concepts, in this case D and F, and concept E, and concept G plus. So the reference, of course, in screening we use the same reference for all criteria, but it doesn't have to be the same reference always for all criteria. So if you want different references for different criteria, you could use. Particularly, there is a phenomena called scale compression. Particularly, if ideally, if the reference is at the is average, if the reference is average for all criteria, then we could get plus and minus from that average for different concepts when you compare. But if it is the best, for example, if the reference is the best, then always the weightage for other concepts will be much less than what you want. So to avoid that, we rather happy to consider different references for different criteria. I'll explain this with an example in the next slide. So step 2 is rating the concepts. So you could either use 1 to 5 scale rating or 1 to 9 scale rating. The rating is of course based on, again, the reference. So the much worse than reference could be rating 1 if in 1 to 5 scale, and much better than reference would be rating 5. So anything in between could be worse than reference, same as reference, better than reference. So you could use the same rating assignment in comparison with the reference. And for example, if your reference concept is the best or best concept, for example, easiest concept for manufacture, then all the concepts that you will be looking at with reference to that particular reference will have either much worse than the reference or worse than the reference or as same as the reference. Therefore, we will never go to better than reference and much better than reference ratings in anywhere in the table. Only 1, 2, 3 will be considered everywhere. Therefore, you will not be using the full rating scale when it comes to assignment in comparison with the reference. Therefore, that particular phenomena is called scale compression. To avoid that, as I said earlier, the different reference concepts may be used for different criteria. So, for example, now in this case, the reference has used the readability of settings. Concept DF is used as the reference, and again for durability, concept G plus has been used as the reference. So likewise, you don't have to stick to the considered reference as the reference for all criteria. So different concepts can be used for reference for different criteria. So this number 3 is the reference for each criteria, same as the reference number 3 if you can recall from that 1 to 5 scale. And now you can see there are better than references and worse than references, like that, for different scores that we have obtained, ratings that we have put in for different criteria. And so that is what I just explained. And of course, the weighted score is calculated by multiplying the weight and the rating. So for example, 10% into 3 is 0.3. And then we can rank the concepts just by adding all these weighted scores together. So you can add all these weighted scores together and get the total score for each concept that you consider. And that is in terms of mathematical formula, it's given here. And based on this score, you can rank them. Again, the ranking is based on the total score, and the highest score is 3.45, that gets the highest rank. And if you want to select only one particular concept for further investigation, then obvious choice is DF. DF has the highest rank, so you decide to continue and further develop the concept DF, for example. And on the other hand, as I said earlier, this is an iterative process. And also, if you look at the numbers, this is 3.45, this is 3.10, and this is 3.05. There is no big difference between these different scores. And of course, this is 2.75. So there is a significant difference from this one to this one. But the difference is not that large in these two. and also with this there is only 0.35 difference. Therefore, these designs may be very sensitive to different ratings that and the weights that you assign. So these weights also assigned. There is no hard and fast rule. That is your experience. So you can change them. So you can slightly change these weights and see how these numbers change, how sensitive this analysis is. So that accordingly you can further refine these problems. And then based on those you can decide combine whether there is any room for combination again and improvement again. And once you finalize it, then you can decide what to select. And when it comes to selecting, as I said earlier, you have to fine tune these weights and see whether these are too sensitive. Accordingly you have to make certain decisions. And as in the previous exercise, that is for concept screening, you could use a spreadsheet to implement this, so that you can easily manipulate these weights and see the different changes easily. And if this uncertainty or the risk is also very important consideration. So even though we are not going to go into detailed risk analysis at this level, so it's always good to keep in mind about the uncertainty or the risk involved in different aspects of this product. Now, if I briefly explain you about the risk, of course, the general understanding is our goal in designing a product is to minimize the risk. So we'll have to make sure that the risk is minimal. And there can be three types of risks involved in this product development exercise. The product risk, that is the product might fail and product might hurt someone or something. And the project risk, that is the project might not move on as you want. There can be failures in meeting deadlines, goals, and meeting the budget, etc. And there can be decision risk. So this time certain decisions that you have made in deciding these certain factors, for example, deciding the weights of this scoring metrics, then there will be a certain risk involved if you do not make the right decision. So risk is when it comes to quantification of risks, it is more or less a probabilistic approach that we consider, and it is an expected value, a probability that combines the likelihood of something happening multiplied by the consequences of its happening. So the things that we need to consider here: what can go wrong, how likely that would happen, and what would be the consequences of this kind of something going wrong. And of course, as I just said, risk is a direct function of uncertainty. Uncertainty is something that unclearness of making decisions. So that is the risk comes due to the uncertainty, and the uncertainty is as I said earlier is can be due to lack of knowledge to make the firm decisions. And when it comes to product safety, that is the main aspect of this particular course. We need to consider two main issues, that is who or what is to be protected from injury or loss during the operation of the product, and how is the product actually implemented in how is the protection actually implemented in the product. Now of course it is the consideration here is not only harming property or person, but also the environmental damage that it could cause should also need to be considered in this safety and risk analysis. Now there are three ways to establish product safety. One is you can design it not to fail, that is design safety directly into the product. So the product inherit safety features, so that should be the best one. So we make sure that the product will not fail. And then we can include protective devices to the product. For example, when you work with the product, so you can give them with a face shield, for example. So you wear face shield and operate the machine. Like that, you can add protective devices, face shields, gloves, and boots and things like that. And then the third one is, of course, you can indicate warnings. So this product, when you're using this, these things could happen. So be cautious about these things, etc. So these are the three aspects of establishing product safety. So you have to include safety features in the design itself. But again, there is no 100% guarantee that you can address all possible scenarios in this one. Accordingly, you can give some safety devices, protective devices for operators. And again, you can't give a 100% guarantee about the safety. Then you can provide some warnings also about the potential danger. And to quantify product risk, there are some procedures. The widely used procedure is this the standard laid down by the MIL STD 882D. This is originally developed by US military purposes. So they have identified different categories of product failures at different levels and associated with certain probabilities, the likelihood of happening certain things, which frequently, whether it could happen frequently or occasionally or remotely, or whether it's not going to happen forever, like different occurrences. And then they have categorized the kind of failures into severity levels. Catastrophic failures, there can be very dangerous things happen, like death or system loss or anything like that. And there can be some critical failures that's kind of harming severe injuries to the environment or the people. And there can be marginal level of severity, and certain things, of course, severity can be negligible. Likewise, they have proposed an assessment matrix based on the frequency of occurrence and hazard category, different hazard categories, and accordingly, based on the numbers that you get, they have indicated hazard risk index, whether a particular risk level is acceptable or completely unacceptable, can be worked out. As I said earlier, I'm not going to expect you to do a proper comprehensive product risk analysis in this particular example, which is beyond our scope. But be aware of the product safety and try to include certain features in the product to avoid any issues which are related to the safety of the product usage. And the two references I mainly considered in this lecture is our standard reference, the Carl Ulrich book on product design and development, which we have been referring right from the beginning. And also I took some sections from David Ullman, the mechanical engineering design process. So with this, I will conclude this lecture on concept selection. And of course, I will upload a guideline for you to and I expect you to look at the designs that you have already developed again, and do a kind of screening analysis as well as scoring analysis, and do some fine tuning, and if required, come up with some alternative concepts by combining what you have done or by improving what you have already done based on the scores that you get. And then select one particular concept for further investigation. So with this, of course, I will finish all these online lectures of this course. So there are a few more things that I want to discuss with you. So you will get at least 4 weeks of in-class sessions once the faculty is restarted. So we could discuss those things during that time. And also I will conduct the last online progress evaluation session on next Thursday, not next Tuesday, next Thursday, and I expect you to present your product concept selection based on the criteria and the methodologies that I just mentioned in this lecture uh, during this progress update session. Thank you.